So this one is classified paper, the thermal physics. We'll solve the question from this. So in the figure, 4.1 shows a Galilean thermometer. This thermometer is used to measure the approximate temperature of the surrounding air. The glass cylinder contains water. When the temperature of a water changes, so does its density will also change. Each bulb has a label printed with a temperature. The bulb have different densities. At 21 degrees centigrade, only bulb A is at the bottom. When the temperature is like 21 is there, so A will be there at the bottom. A is at the bottom. So what this give an idea? If A is at the bottom means A is having a high density. That's why it is at the bottom. Because as the temperature of a water changes, its density will change. As its density will decrease, so comparatively, like as the temperature will rise, more of these bulbs like B, C, D, and E will sink towards the bottom. So the first part, explain in terms of density why a bulb A is at the bottom of the cylinder and other bulbs are floating. So this is related to a density, like why you see bulb A is at the bottom and other bulbs are still floating. So what is the reason for that? What you can conclude from this? You can say density of the bulb A is greater than the density of the water. That's why it sinks. Where density of the other bulbs is less than the density of a water, that's why they are floating. As this was a question, why the bulb A sink where other bulbs are still floating? So what will be your answer? You'll mention because the density of A is greater than the water and the other bulbs density is smaller than water, that's why, or lower than water, that's why the other bulbs are floating. Because if a density of object is high, the object will sink, and if the density is low, the object will float. The next one, the temperature of a surrounding air increase to a temperature above 23. Suggest one reason why there is a delay before the temperature of a water increases to 23. Look, remember, in because the heat energy is transfer in a liquid. What method or by which method heat energy is transferred in the liquid is by convection. Like when group of particles will move up, the cold molecule will move down. So this convection is not instant, like it does not instantly happen. So what is the reason for the delay of a transfer of energy, or why the temperature of a water does not changes to 23 instantly? Why it takes time? So you can mention like the heat energy transferred through a water is by convection, and water is not a good conductor. So it takes time to transfer the heat energy. Or water is having a high specific heat capacity. When a substance is having a high specific heat capacity, it will absorb greater amount of energy before it changes its temperature. So suggest like the temperature, one reason why there's a delay. So you can mention water is not a good conductor. Good conductor of heat. Or you can also say water is having a high specific heat capacity. So whenever objects have or a substance is having a high specific heat capacity, it will absorb greater amount of energy and show a very small change in temperature. So it take much longer time for the transfer of heat energy. Explain why after this delay, the bulb B sink, assume that the bulb does not expand. So what will happen in the figure? They're saying when the temperature rises to 23, why the bulb B will sink. So when the temperature is rising, the density of the bulb is not changing. Density of a water is changing. So first thing, what will happen when the temperature will rise or temperature will increase, the volume will also increase. That is the first thing. If a volume is increasing, what happened to the density? Density is mass present in a unit volume. So if the volume is increasing, the density will decrease. So as a result, what will happen? The water density will decrease and water density will be less than the density of a bulb. So this bulb will also sink. So how to write the answer for this one? So what will happen when the temperature increase or temperature rise? The water expand or the liquid expand, which decrease the density, and as a result of a decrease in density of a water, the density of a bulb, so the density of a bulb B is greater than the density of a water, so it will sink. Is it clear, this question? Anyone having a doubt till this point? Any question or doubt till this point? Okay. Moving on to page 2. The next one, bulb A, B and C are now at the bottom, but D and E are floating. State the possible temperature range. Look, as you see, when the temperature was 21, when the temperature was 21, A was down. When a temperature is 23, B is also down. Now they're saying in the question they mentioned, we have bulb A, B and C are now at the bottom. So C is also there at the bottom. C also sink. The label on the C is 24. So what should be the temperature of a water? D and E are still floating, but C sink. C will sink if the temperature is 24 or above. So what could be the temperature? So the temperature of a water will be, that's right, that will be 25. Because the idea is that if a temperature, these labels shows at 20 degree A will sink, at 22 degrees B will sink, at 24 degrees C will sink. So means the temperature should be like 24 or above. So as they ask for a range, we can mention a range like it can be from 24 to 26 as D's, because in the question they ask state the temperature range. So what will be the temperature range? Because it cannot be above 26. The temperature cannot be above 26 because at 26 the D should sink. Like if when the temperature is above 26, the D will sink. So only A, B and C sink. So it means the temperature is either from 24 to 25 or 24 to 26. That's a range of a temperature. So this is a Galilean thermometer which can be used to work out the temperature. How we can use at different temperatures, surrounding temperature, different bulbs will sink. Each bulb is having a label. So if the temperature of a surrounding is above 20, A will sink. If it is above 22, B will sink. If it is above 24, C will sink. So different bulbs sink at different temperature range. So this was page 2 now. Page 2, the second part. State two ways in which evaporation is different from boiling. You can also use the chat. You can also use your mic, or you can also type on the available space here how evaporation is different from boiling. What is the first difference between evaporation and boiling? So we can say yeah, that's right. Evaporation take place. Evaporation has no, it's opposite. Bubbles are formed. Yeah, in evaporation, no bubbles, but boiling bubbles will form. So first thing in evaporation, and in the boiling there are bubbles formed. What is the second difference between the boiling and evaporation? Yeah, that's right. Evaporation occur at range of temperature, at any temperature evaporation, or evaporation happen at the surface, where the boiling occur throughout the liquid. So throughout the liquid, the boiling can happen. Then give one example of a change of a state which does not involve boiling or evaporation. Like when the substance is changing a state, but that does not involve boiling or evaporation. So what example? You can say melting of ice. So when the ice is melting, it's not boiling or evaporation, but it is changing the state. Or you can also say freezing of a water, that you can also refer. Moving on to page 3. This is a cooling curve. How you identify it's a cooling curve? Because you can see the temperature is decreasing. So in a cooling curve, the temperature decrease. So first, like a substance cool down. The graph in figure 5.1 shows a variation of a temperature with time for a substance that is initially liquid. So first we have a liquid here. Liquid is cooling down. Then a liquid is turning into a solid, that is freezing. And then we will have a solid only. These are the states which exist at different positions. So at A we will have liquid, at B we will have liquid and solid, and C will have solid only. The question is state what is taking place at point A, B and C. You should say what change of a state, if any, are taking place. So what is happening at point A? Point A, there is no change in state because point A, the temperature is changing. So you can say that the liquid is cooled down, or it's a cooling of a liquid. But there is no change in state because still the temperature is changing. Whenever there is a change in temperature, there is no change in state. What about point B? What happened? A liquid is freezing. And what about point C? Again, it's a solid, so it's a cooling of solid. So the solid substance cool down, that is happening at point C. Moving on to the next suggests why the graph is steeper at point C than at A. Like when you compare, the C is much steeper, like it has a greater slope as compared to that of A. So what might be a reason for having a different gradients or different slopes? This is because, as I mentioned, it is related to the concept of specific heat capacity. When the specific heat capacity, as you can see here, for means when we the substance is a solid here, and substance is a liquid here. You can see the temperature of a liquid, the change in temperature for a liquid is smaller as compared to change in temperature for a solid. Like this part, the solid is having a greater. So remember, you can relate with the specific heat capacity here. How you can relate the specific heat capacity? Specific heat capacity is energy divided by mass and temperature change. If we have a smaller temperature change, it means the substance will have a high specific heat capacity. And those substances which are having a high specific heat capacity, they will show a smaller change in temperature. So what is the reason why the graph is steeper for solid and it is less steeper for a liquid? So less steeper means that it has a the higher specific heat capacity. So you'll say liquid is having higher specific heat capacity. When it has a higher specific heat capacity, it will show small change in temperature. So remember, whenever you are comparing a temperature changes, like some substances have a smaller temperature change than the others, so you can relate them with a specific heat capacity. The one with a smaller change in temperature, high specific heat capacity. The one with a greater change in temperature will have a smaller specific heat capacity. Is it clear, this one? So always try to relate the specific heat capacity and the temperature changes. The answers are also given after each question. The answer is there. This one is page number 4. Figure 6.1 shows an apparatus that is used to demonstrate some effects of the transfer of energy by radiation. So we use electrical heater and two sides are there, two bulbs are there. One is painted matte black, means dull black. Another one is a shiny, and there is a air present in both of them inside the bulb. So what will happen? Because we know dull and dark surfaces are good absorbers. So when heat energy is given out from the heater, most of the energy is being absorbed by the dull and dark. But for a shiny and the smooth surfaces or polished surfaces, it reflect the heat energy. It will absorb some, but not too much. So as a result, what will happen? The air in the dull and like a matte black surface, this air will be at high temperature. When this air is at high temperature, it will exert more pressure because the particles will move faster. So as a result, when the part and here what will happen? The temperature will be lower. As a result, the particle will move slower. So what will happen to the levels? The side which is a matte black, that side the level of the water will decrease. Why it will decrease? Because there is more pressure from the air. As a result of a high pressure, the level of that side will decrease. And other side, what will happen? The pressure from the other side will increase, like the liquid level will rise other side, because if we compare the pressure of the gas on the left and the right, the left hand side, as it is dull and dark, it exert more pressure as compared to that on the right hand side. This is what happened in this experiment. So now the question is the glass bulb painted matte black and the shiny glass bulb and the space above the liquid in the tube all contain air. The heater glows red when it's switched on. The heater is at same distance from each bulb. State the two types of radiation that are emitted from the heater. Look, two types of radiation, because the heater, we are able to see it is giving us a red, like it become red hot. So it means it is giving a visible light or visible radiations. And what else is there? Because it is also give heater is there, so it will give the heat radiation, which we call infrared. So what are the two types of radiation this heater is giving out? One is a visible, another one is a infrared, or you can also say heat radiation. So whenever you switch on, like example, burning a fossil fuel, like you're burning a coal, so you will feel the heat from that coal as well, and you can see it become red hot. So why you're able to see it's red hot? Because it is giving a wave, a radiation in the visible region, and that's why you will see its color. And you will also feel that your skin can feel the heat energy which is also released, and that how your skin can feel that heat energy is by the infrared radiation, or also known as the heat radiations. In page 5, before the heater is switched on, the liquid levels in the glass tubes are same. State and explain any change in the liquid levels that take place when the heater is switched on. So this is the same answer you have to write, like as I explained to you. First thing, one mark for mentioning dull and dark surfaces or a matte black surface is a good absorber. So 1 point you will score when you mention that the matte black is good absorber, then shiny. And the second mark, shiny are good reflectors, shiny surface. That will score the second mark. So the temperature of air on the left hand side increase more than right hand side. As a result, the air exert more pressure from left, so the water level will fall on the left and it will rise on the right. So this is what happened. It's the same thing, same explanation is there. Like dull and dark surfaces are good absorber than shiny and smooth. So as a result, what will happen? Shiny and smooth surfaces are good reflector. Like 1 mark is for mentioning dull and dark surfaces are good absorber. 1 mark is for mentioning shiny is a good reflector. 1 mark is for mentioning the temperature is high, so the pressure will be high. And 1 mark for mentioning that level will be lower on the left hand side and it will rise on the right hand side. Is it clear? This one? Any doubt in this? As I mentioned, while explanation of a thermal physics, as I mentioned, most of the questions are theoretical question. Very few calculation part is there. Most of the question based on your understanding and how you write the answer. But try to learn the structure of an answer so that you won't miss a point. Moving on to the next page, page 6. In page 6, figure 4.1 shows a cold plastic spoon that has just been placed in a hot liquid in a cup. So there's a plastic spoon is there and we place it in a hot liquid. Describe in terms of molecules, why the temperature of the whole spoon increases. So in terms of molecules, we have to explain why there's an increase in temperature. Even though it's a plastic spoon, plastic is not a very good conductor, it's an insulator. But what will happen? There are molecules in the liquid, because we have to explain in terms of molecule why the temperature of the spoon is increasing. So the molecules in the liquid, as a liquid is at high temperature, so the molecules of the liquid are moving fast. As a result, the molecules of the hot liquid will collide with the spoon, the surface of the spoon, like they will hit the surface of the spoon. As a result, when they will hit the surface of the spoon, they will cause a vibration of the spoon molecule. As a result, its temperature will increase. Means the part of the spoon, it's not like when you hold it, it will be very hot. The part of a spoon which is inside the hot liquid, which is exposed to the hot liquid, it will be at a high temperature as compared to other parts. The temperature of a whole spoon will rise, but the increase in temperature for the part which is directly exposed to a liquid will be much higher. So how you will score the marks? The marks distribution, first thing, molecules in the hot liquid are moving faster. As a result, they will collide with spoon, surface of the spoon. When they will collide with the surface of spoon, they will transfer energy, which cause the molecules of spoon to vibrate and increase the temperature. So it's of how many marks? 3 marks are there. But if you see the answer, it's very simple. It's just the idea that like how to write an answer that is important for thermal physics. It's not like answers are difficult, but it's like relating the things with each other. Hot liquid particles are moving faster. They collide with the spoon surface. They transfer their energy. It causes the spoon particles to vibrate, and that increases the temperature. The next question. The plastic spoon is replaced by a metal spoon. Describe an additional process by which the temperature of a whole of this spoon is increased. Like first we were having a plastic, but now this plastic spoon is being replaced by the metal one. So what will happen as a result? Like what additional energy transfer? Because what will happen, the molecule when the molecules of the hot liquid will collide with the spoon, it will cause two things: the lattice vibration as well as the movement of electrons, because they ask for additional. Like additional, what will happen, how the energy is being transferred. So describe additional process by which the temperature of a whole of this spoon increases. So the molecules of the hot liquid, they will collide with the molecules of the spoon, and another thing what will happen, it will cause lattice vibration. and the movement of free electrons from high temperature to lower temperature. In exam, don't write temperature as TEMP. You should write as complete. I'm writing in short, but don't write in short. So write the full temperature. The next question, it is related to the cup containing 150 grams of a liquid. So first, whenever you're solving any question, first try to identify what are the quantities, the physical quantities given to you. The best way to identify the type of the physical quantity is by units. Like we have 150 grams, so means this is mass is given. Here it's given specific heat capacity is there. Look, specific heat capacity is 4.2 joules per gram. If the specific heat is in gram, I don't have to convert the mass into kilogram. Mass should also be in gram. If the specific heat capacity was in kilogram, then I should use the mass also in kilogram. When the cold spoon is placed into a hot liquid, the temperature of a liquid decreases from 80 to 56. Calculate the thermal energy lost. So what is the formula which is relating the thermal energy and the specific heat? So E is equals to Cm delta T, as the specific heat is energy divided by mass and temperature change. So E is the energy loss or energy gain. That is a specific heat, which is 4.2. M is the mass. You will take 150. Don't convert into kilogram, as the specific heat capacity is given in joule per gram. So you don't have to convert into kilogram. And the temperature change, it's greater minus smaller. So it will be 80 minus 56. When you multiply them, what's the answer for this? 4.2 times 150 times the temperature change, 80 minus 56. What's the final answer in joules? The temperature change, 150 times 4.2 times the temperature change. Yeah, what's the answer for this? 4.2 into 150 times 80 minus 56. 15,120. This is 80 minus 56, 15,120, and the unit will be joules. Marking scheme answer, usually rounded off answers are there. So in the marking scheme answers are, so you just have to multiply and you get the energy lost. Don't need to round off, as it's usually rounded off answers are there. You can write in exponent scientific notation, but no need to round off. The next is page 7. So we have figure 5.1 shows an apparatus used to observe the motion of the smoke particles. This is related to Brownian motion. Light from the lamp entered the box through a window. On one side, the smoke particles are observed using a microscope fixed above. And page 8 is actually, we have to write. We have to draw the motion of a single smoke particle is observed through a microscope. Sketch the path. Look, the common mistake what students do here, they draw like shows a Brownian motion, a random motion of the particle like this. That is wrong. Why this is wrong? Because it should be for a short distance, it must be a straight line. So there will be no specific direction, but for a short distance, I must draw straight line. The next one, explain why the smoke particles follow the path that is observed. So draw the always whenever you're showing a Brownian motion, it is always short distances and it will be a straight line. Random changes, short distance, straight line. So what is the reason why the smoke particle follow this Brownian motion? So answer as a structured answer is there because these lighter, like the smoke particles are hit by the air molecule which changes. So the lighter air molecules collide with lighter air molecules are moving randomly. That is the first point. As they're moving randomly, they collide with a heavy smoke particle. And when they collide with the heavy smoke particles, what will happen? This will cause a random motion. Exert force and cause a random motion. The next one is actually related to momentum. A tennis player is practicing by hitting a ball many times against the wall. The ball hits the wall 20 times in 60 seconds. The average change in momentum is 4.2. Calculate the force. So how to work out the force? Impulse is force multiplied by time. So if we need the force, force is impulse divided by time. So what is the impulse here? The change in momentum is given 4.2. That is the change in momentum. And 20 times in 60 seconds, like, so what is the time for one? So it will be 60 divided by 20, which is equals to 3. Because like for each time, because the ball hits the wall 20 times in 60 seconds. So how much time the ball will take for one time? So it will be the total time divided by the total time interval divided by the number of the time which is hitting. So that is 60 divided by 20, which is 3. So 4.2 divided by 3, what we'll get? We'll get 1.4 Newton. That will be the force. Is it clear, this part? So whenever you're solving a question, 1 mark is always writing a formula. Like you will score 1 mark for writing a formula, 1 mark is for getting this time for one, and 1 mark is for the final answer. That's how you will score the 3 marks. So I'll share another link and we'll continue this thermal physics.